Okay, next we're going to do a quick little review of working with polynomials. So here we've got some definitions to go by. I've used some of these already in the previous video. First we're going to look at what a term is. Here it says a term is a number or a variable or the product of numbers and variables. So what that means is your term could be the combination of both of these. So this has what we usually call a coefficient, but more formally is called a numerical coefficient, the numeric part, and a variable part, which we formally call a literal coefficient. And these are always being multiplied. So these together make up what a term is. But a term could also just be using one of those things. So a term could just have a numeric part, or a term can just have a variable part, where then the numerical coefficient is going to be a 1, or it could be both of these being multiplied. So there's a couple of examples below that. Here, this is a term where the -2 is the numerical coefficient, the x to the 4 is the literal one. X by itself is just a term because that's the variable part. However, the numerical coefficient in front, there's always an implied 1 there, just like there's always an implied exponent of 1. And then 5 is also a term because it is just a numerical coefficient, but if you really want to be technical about it, the variable part is an x to the 0, because anything to the 0 is a 1, so it's like saying 5 times 1, but we'll just say 5. Now when we talk about the word polynomial, then what polynomials are, they are made up of just single terms or potentially sums and differences of multiple terms. So here this is a polynomial, even though it's just made up of one term. Here's a polynomial, it's made up of 2 terms. Here's a polynomial made up of 3 terms. And what you guys should have seen at least last year is that some of these polynomials have more specific names. So if I had, let's say, that example that only had one term, we call those monomials. If we had a polynomial that has 2 terms, it's called a binomial. If it has 3 terms, it's called a trinomial. Anything more than that, then we just revert back to the generic form and we say polynomial. All of these, though, are polynomials. It's just that these first 3 have also more specific names associated with them, but they are also still polynomials. Okay. After that, we look at what is called the degree of a polynomial, of a term. And how we determine the degree of a term is just by looking at the sum of the exponents. So the sum of the exponents on the variable parts, on the literal coefficients. So here, this term, it has a degree that we would call 3. Here, it's the sum of the exponents. So the degree here is an 8. And then here, the degree would be a 1, and then here there's no variable part, but remember, when the variable part's not there, it's really an x to the 0, which means this has degree 0. Okay, when we talk about degree of a polynomial, not just a specific term, then we look at what is the greatest degree of its term, which means we look at each individual term in the polynomial, and whichever one has the highest degree, that's the degree of the entire polynomial. So this one only has one term, so the degree of the polynomial is going to be 3. Here, this has degree 8. This one's going to have degree, remember there's implied exponents there, so this has degree 8, this one has degree 2, this one has degree 0. So I take the largest one, which in this case is an 8. Okay, here I'd look through each term. So this is degree 5. This one has degree 5 as well because of the implied 1. This has degree 6. And this one has degree 3. So take the biggest one, degree 6. And then last one here, this is degree 9, 3, 7, 8. So whichever is the highest, which was the first one, it was a 9. This is degree 9. Okay. When we talk about simplifying polynomials, then we try to collect like terms. Okay, so these are terms that have, like it says here, the exact same literal coefficients, so exactly the same variable parts with exactly the same exponents on those variable parts. So here, if I want to collect like terms, I'm going to collect all the x's. They are of the same type. So I've got 5 of them. I'm going to add 3 of them. So I've got 8. I'm going to add, let's say, the constants. -2 plus 4 is a +2. And then here's the y's, -9y. And if you remember back from the beginning of the course, this is correct, but if you want to write it in proper form, then we would just reorder it so that it is alphabetical. Constants always come last. Okay, over here, I'm going to look for like terms. So here I've got x squared. I want to look for things that are also x squared. So I've got 2 of them. I'm going to add 3 of them. So I have 5x squareds. Then I've got things that are x's. I'm down 1, but I add 4 back. So I've got 3 x's. And then I've got these constants, 6 and then -5, so +1. And it's in the right order, where if it's not alphabetical, then what we could do if they're the same letter, then we do in descending degree. So this has degree 2, then degree 1, then degree 0. Okay, also with simplifying polynomials, we could try to distribute some stuff, and this is going to use some of the exponent rules. So here I've got a monomial and a binomial, which means the monomial distributes to the binomial. So this is going to be a 5x times 3x minus, that's the sign that's there, a 5x times 2. So if we multiply these together, then these are powers of the same base that are being multiplied, and the coefficients get multiplied. So 15x squared, so powers of the same base, they're all to the exponent 1, so add the exponents, minus 10x. Okay, and then these are not like, they can't be added. For b, here's a monomial, and it is being distributed because it's being multiplied by a trinomial, which means I'm going to have a 3x squared times a 2x squared minus a 3x squared times an x plus a 3x squared times a 6. And then use your exponent rules again. Here I've got 6x to the 4 because I'm adding the exponents, minus a 3x to the 3 plus a 18x squared. Okay, down here when I have brackets, I'm going to need to distribute if I want to take things out of the brackets. So there's an implied 1 that's here. And with that implied 1, if I try to distribute this, everything is going to stay the same. If I distribute this for that 2, then this is going to be a 6x plus 8. And then when everything's out of the brackets, then I can go forward and collect like terms. So I can have 5x's and 6x's is 11x, and then minus 2 and plus 8 is a plus 6. Okay. And over here we've got a little bit more going on. This 3 needs to be distributed first. And then here, the subtraction, it's actually like a -1 being distributed, or you could just say I'm subtracting everything inside that bracket, which is going to change that sign, change that sign, change that sign. And then everything's out of the bracket now, so go and collect like terms. So let's get these. So that's going to be a 3x squareds minus 2x squareds is just an x squared. Here I've got an x, here I've got an x. So I've got a -6 and I'm subtracting 3, so minus 9x's. And then the constant terms with no variables, I'm down 9, add 4, so I'm only down 5.